Hey everyone, in today's lesson we're going to be looking at multiplying and dividing terms with the same base. So our learning intention is that you understand that index laws for multiplication and division can be used to simplify and speed up the processes when we're working with terms that have the same base. To understand this, we need to think about what index notation means. Now, index notation is a way that we can represent repeated multiplication of the same number or term. So if we think of 2 times 2, we can represent that as 2 squared, and that's showing it in index notation. Now, when we're using index notation, there are some key terms that are used, which are the base, and the base is the number that is being multiplied. So in the above example, it was 2. Here we're looking at A being the base. And then the other term that we're interested in is the one that we call index. Now, index is another name for power or order. So our index is the power that the base is raised to. So that is our index there. So what this means is, if we have 2 squared, instead of writing 2 times 2, we can write it as 2 squared. And instead of writing 2 times 2 times 2 times 2, we can represent that as 2 to the power of 4. Now, it doesn't matter if it's a number or if it's an algebraic term. Remember, algebraic terms are just numbers. So if we had a times a times a, then we can represent that as a cubed, and a squared would be a times a. So when we think about multiplying with indices of the same base, we're going to first consider what that actually means. So we have the expression 2 to the power of 3 times 2 to the power of 4. We know that 2 to the power of 3 is 2 times 2 times 2. And 2 to the power of 4 is going to be 2 times 2 times 2 times 2. What we have is 2 times 2 times 2, which is our 2 to the power of 3. And then we have our 2 times 2 times 2 times 2, so we have 2 to the power of 4 there. And if we total all of those 2's up, we can see that we have 7. So our answer to 2 to the power of 3 times 2 to the power of 4 is going to be 2 to the power of 7. Now, what do you notice between what we have as our powers in each of these cases? So we've got 3, and we've got 4 in the original expression when we're multiplying, and we're left with 7 in our final answer. So what do you notice about the indices of what we started with and what our answer is? You can see that we have added the indices. So what this means is the index law for multiplying indices with the same base means we've got a to the power of m times a to the power of n can be replaced with a to the power of m plus n. So we just need to add the powers together. And there are some key points that need to be considered when we are looking at using this rule. Firstly, in order to use the rule, the numbers have to be the same base. What that means is I can do a to the power of 3 times a to the power of 4. That's okay to use these rules. But if we were looking at a to the power of 3 times b to the power of 3, then here we cannot use the rules because what we have is different bases. Now, next thing we need to remember is if we have a number all by itself, such as x, and we are multiplying that by x to the power of 3. Now, we need to consider that that x is there, which means, whilst it's not shown, it has a power of 1, which means we're going to have x 1 plus 3, which gives us x to the power of 4. Now, if a polynomial has a letter or if the pronumeral, which is the letter, has a coefficient or number in front of it, then you need to remember that the coefficient is not part of that base. If I have 2x to the power of 3, I do not have 2x's. Remember that hiding in between here, which is just not shown, is a multiplication sign. So what that means is 2x cubed actually means 2 times x cubed. So you can see the index is only attached to the x. And terms that have multiple pronumerals or multiple letters can be separated into the different bases when we're multiplying. So if I have got a cubed b to the power of 4 times 2a squared b to the power of 4, then what we have here is 2, and then we look at the a's, and we have got 3 plus the 2. We are drawing together these two here. And then if we look at the b's, we can see we've got 4 here and 4 here. So we have got b 4 plus 4. And if we simplify that, we will get 2a to the power of 5, b to the power of 8. So you can see it doesn't matter that our terms had different powers. We just separate the different bases because remember, between all of these, we have that multiplication sign here, here, and here. And it doesn't matter what order you're multiplying in, the numbers work out to be the same. So we can switch them around to suit us. So let's do some examples together. We have got 3 squared times 3 cubed. Now we could expand that out and we could have 3 times 3 times 3 times 3 times 3. And we can see we can get that to be 3 to the power of 5. Or, using our index laws, we can just say 3 squared times 3 to the power of 3 is equal to 3 to the power of 2 plus 3, which gives us 3 to the power of 5. You can see it's a much quicker way to get to our answer. So now we're going to look at our next example. We've got 4 times 4 to the power of 5. So now we know we've got 5 4s here, and here we have 1. So we put that little 1 there, and what we have is 4 to the power of 1 plus 5, which is 4 to the power of 6. It doesn't matter if we have more than 2 numbers. If we look at our next example, we can say we've got 3 different groups of b, but what we do notice is all of them have the same base of b. So what that means is we have b to the power of 3 plus 1 plus 10, which is equal to b to the power of 14. You see that is much quicker than rewriting all of that out in expanded form. If we look at something which is involving coefficients, remember we can switch these around in whatever order we want. So we can change that to be, taking into account we have those multiplication signs there, 3 times 5 to take care of the coefficients, times m to the power of 2 plus 4. Now we know that 3 times 5 is 15, so we have 15 m to the power of 6 as our answer. So you can see we've got into all of our answers very quickly along the bottom there. Looking at terms that have more than one pronumeral, we just join the pronumerals together. So we're going to join the x's together. So we have got 2 in the first group plus the 3 in the second group. And then we're going to join the y's together. So we have the 1 which is not shown plus the 5, and we have got x to the power of 5, y to the power of 6. And for our final example here, we can see we have got 3 times 2 times the a's, which is 2 plus 1. And then we have the b's, and we can see we only got that one b there, so it's going to stay as it is. And we are left with 6a cubed b. So you can see all we're doing is just when we have multiplication, we are just adding those terms together.